For this video, we're going to take a look at creating our first metric drawing in millimeters. When we create a metric drawing, our units will always be in millimeters. On the portal, you will find the metric template. I'm trying to find it. And as you open this metric template, it will open by default in AutoCAD. Shouldn't be too big of a deal. On screen, you should not find any real differences. The only difference is that when you key in dimensions now, they're in millimeters. Now, being that the first time that you were using this template, we want to go back and set up our snaps. So if you want the grid on and off, do you want the polar snaps or the grid snap? We've been using the polar snaps. Another one is your angle increments. I'd stay at 15 degrees. End point, middle point, center point, tangency, quadrant point, sorry. These are, I just go back through and check. Because as you have made changes in your inch drawing, those changes are taking place here. In terms of dimensioning format, we'll worry about that after we create our first part. But drawing lines and rectangles, circles, everything's the same except you're putting in millimeters now, which shouldn't be too hard of a concept to grasp. Actually, I find it easier. Maybe that's just me. I don't have to put in fractions of an inch. It's very rare that you'll see decimals at all in metric drawings. So when I went to go and input something like the length of a line, instead of putting in inches, I am now putting in millimeters. And when we start with this first one here, which I did open, the guide block, it's 110 by 50 and it's 50 millimeters wide. We have a couple notches cut into it. Top, front, and right side view. Orthographic projection. All of that remains the same. The difference is your input of dimensions is now in millimeters. And when you go to dimension, we will have to set dimension text size. We will have to change the precision. Typically a 0 precision, no decimal places. It might be rare that we have 1. But we're going to go ahead and create this part. So being it's 110 millimeters long, it is 50 millimeters tall. Front view. Spacing in between. We were using a 1.5 inch for the parts that we were creating. For inches, 40 should put us, right around 1.5 inches. So I'd stick with a 40-inch gap between the top, front, and right side views. And this is 50. And for this one, features like mirroring would also be good ones to be using. It is symmetrical, actually in all 3 views. But I actually find it easier because I can input whole numbers. I don't have to put in decimals. I don't have to put in fractions. I added 100. So just in terms of orthographic projection for our top, front, and right side views, really no problems whatsoever. As you start to use tools, you may find that the snap points are what you plan them to be or what you desire them to be. You can most certainly go back in and make that change as needed. So from here, we're just going to keep on adding our dimensions. I would recommend mirroring this actually in all 3 views because the dimensions are the same in all 3 views, or they're symmetrical in all 3 views. 35 here across the bottom. We have a vertical distance of 20, and that's back to the middle. This one is a total height of 10. It comes over 20 and right up to the top. And I do have a small cutout here at the top. So if I go 20 over and drop down 10, I can now mirror this to the opposing side. So just because we're in metric, mirroring is not affected, rotating is not affected, trimming is not affected. And I do want to keep it. So there's my front view. I will have a hidden line that goes across here. But at this point, I am just projecting to the other views. There'll be a hidden line here. This will be an object line. And I do have these two little notches here in the top, or two little bosses that create the notch in the top. 10 millimeters over, 20 millimeters down. What would that be? 30. So I will have a little hidden line section right here. This will be a hidden line. This will be an object line. So I'll trim this one off. So another thing that you don't have is you don't have your line types loaded. Metric is a little bit different. We were in the habit of using hidden 2, and I don't have hidden 2 here, and I also don't have center 2 here. And this is probably one of the bigger problems, is the line type scale is what it's known as. So if I hit hidden 2, and while I'm in here I might as well load center 2, because that's what we're using. When I go to create that line type, hidden 2, hidden 2 works out okay. When I change this, not that this one has center lines, but when I change the center to, the line type is very, very small. Sorry, very big. And typically when we drill holes, we're not drilling through this much material. We are actually going to change the line scale when this does take place. But for this one, we're just going to continue using our hidden 2. So we're not reinventing the wheel per se. And I will now project over and across to get this as a hidden line using hidden 2. We don't want to have to change every aspect of what we have been doing just to convert to millimeters. The one thing that we will change when we have these center lines later will be to change our line scale, but we'll worry about that when that happens. And I would mirror this one. Instead of changing all these line types multiple times, and the same thing up here at the top. Instead of changing these line types over and over, I would just create them once and then mirror it all at one time, being that it is symmetrical. And we have looked at mirroring before. So this is an object line, but this one here is a hidden line. So I'm going to change this to hidden 2. All object lines, that's the step up. This one comes back, and this one comes back. And I should be ready to mirror this to the opposing side. So an object line, this one gets trimmed. Alright, so I should be able to mirror this to the opposing side. in creating the drawing for the guide block.